I'm going to look at an example of, you could think of it as either being a cathode ray tube, which is the old-fashioned phosphor television screen, or in combination with mass spectrometer, what would be the initial stage, which is a velocity selector. Essentially, this is the idea of using crossed electric and magnetic fields to steer a beam of charged particles. In this case, like cathode ray tube, we're using a beam of electrons, so the charges have a negative charge. We have a velocity that we know is to the right, but we don't know what the speed is. We know that there is an electric field caused by capacitor plates that is 200,000 newtons per coulomb and points up the page. And we want to find, if the magnetic field magnitude is a Tesla, what direction it has to point. So we want to find the direction of B and the speed. So there are two forces that are going to be acting on the beam of electrons. So we can write out an expression for that net force. Part of it is a Coulomb force, so Q times the electric field, and then part is magnetic force, which would be Q times the vector cross product of V cross B. We want those to sum to 0. And since they sum to 0, we can divide this equation out by Q. And we'll have a statement then about the vectors that we want the electric field plus V cross B to equal 0. All right, so let's work out some of the directions of things. So the electric field points up, so the Coulomb force on a negative charge is going to point down. If the force on a negative charge due to the electric field points down, that tells us we're going to want to have a magnetic force that points up, because then I could get these two vectors to cancel out and sum to 0. So now I know the magnetic force is going to point up the page, and the velocity points to the right. So what direction of a magnetic field is going to make that true? Okay, so if we try that out, we'll see that a V cross a magnetic field coming out of the plane of the page will give me V cross B that points down the page. And since it's a negative charge, that gives me a magnetic force that points up the page. So the direction of the cross magnetic field has got to be coming out of the page. So we can fill that in. And that's the positive z hat direction, in reference to our coordinate system. All right, so we have the direction of the magnetic field figured out. Now we should find the magnitude of the speed, or magnitude of the velocity, which is the speed. So in terms of magnitude, if I have a speed that is E over B, then I will have the right magnitude of V cross B magnitude to cancel out the electric field in this equation. So let's try to see how that's going to work out. So this equation is telling me that as a vector, E is going to be equal to minus V cross B. The magnitude of V cross B is going to be the speed times the strength of the magnetic field times the sine of 90 degrees, because the velocity and magnetic field are at right angles. So that's just a 1. And then the magnitude of the electric field is obviously just E. So in terms of magnitude, we're just looking at an equation that E is equal to V times B. Therefore, V is E over B. So using the numbers in the problem, that is going to be 2 times 10 to the 5th newtons per coulomb over, well, a nice round 1 Tesla, which a Tesla is a Newton per meter per amp. So this is going to be 2 times 10 to the 5th. The newtons cancel out. So I'm going to have a meter times an amp over a coulomb. And then an amp is a coulomb per second. So the coulombs will cancel out, and this is in fact a speed. So 2 times 10 to the 5th meters per second. So these crossed electric and magnetic fields will allow a particular velocity for a charged particle to pass through them undeflected. And if the speed is greater, then magnetic force is going to dominate and it'll curve. And if the speed is lower, the Coulomb force is going to dominate and it will curve in the opposite direction. So either way it'll be deflected, and it's only for a particular velocity it'll pass through the crossed electric and magnetic fields with no net force. So that's the velocity selector part. In terms of a cathode ray tube, the way you would make a picture is you could cycle through charge on the capacitor to vary the electric field, or charge in loops of wire that are making the magnetic field, and steer this beam of electrons to address all of the different phosphor dots along a screen. And it would just have to cycle through all of those dots, illuminating where those would be red, or green, or blue at a given intensity in the color screen, fast enough that our eyes would blur it into like a continuous motion. So we wouldn't see the raster scan across all the different picture elements in the screen, which is an electronic system, so it's pretty easy to do it that fast. There we go. So the cathode ray tube, or alternately using crossed electric and magnetic fields as a velocity selector.